This assessment asks us to draw the Newman projection down the 2,3 bond for the most stable conformation of the molecule shown. I've gone ahead and drawn the two possibilities for how we're going to start, and we're going to use our cartoon person here, yes, that's meant to be a person, to help us do this. What we first notice is that the CH3 group is in the plane of the page and is by the viewer's chin. As a result, right, if we're looking down and it's by the viewer's chin, with me now as the viewer, we're going to use this to start our Newman projection. We're not going to worry about that one. Okay? The next thing we can do, that allows us to go ahead and label that as a CH3. And what we notice is that bromine that's on a bold wedge is coming out towards the viewer. Our viewer then is going to see that bromide near its right ear. So we'll put the bromine there. The hydrogen would be here. Now, looking down this bond, we see that the CH3 in the back is also in the plane of the page, or the same plane as the CH3, so we'll put that one here. That gives us the clue that this is a staggered conformation, which is good because the most stable conformation will be a staggered conformation. The chlorine that is on a wedged bond, or a dashed wedge bond, is now going to be pointing to the left side of our viewer. So the left side of me is going to put the chlorine here and a hydrogen here. Now, this gives us just one conformation. There are going to be two other staggered conformations. Let's draw those by keeping the front the same. And so we'll draw them here and here. We'll keep the front the same in both. And we'll rotate the back. And we'll take that back and rotate it 120 degrees counterclockwise. So the CH3 goes from here to there, hydrogen moves to here, and chlorine moves up. Do the same thing on the bottom, except we'll rotate the other way. Instead of going 120 degrees clockwise, we'll go 120 degrees counterclockwise. So up here, the methyl group went that way. Now we're going to have the methyl group go this way. So we'll put the CH3 over here. The hydrogen is up. And the chlorine is to the right. This gives us the three staggered conformations. How do we choose between them? Well, we're going to look for the structure that minimizes the gauche interactions. Let's highlight the gauche interactions. We can do that using a different color marker here. We've got a gauche, and a gauche. So for a total of 3 gauche, that's a G, a total of 3 gauche interactions there. In terms of this one, we've got 1 gauche, 2 gauche. Remember, the gauche interactions are the 60-degree dihedral angle between non-hydrogen substituents. So we've got 2 in that one. We do the same thing. We've got 1, 2, 3 gauche interactions. Each gauche interaction contributes to instability, and so we're going to choose the one that has the fewest. The first one we drew is the most stable conformation.